In this video, we're going to learn how to simplify powers of I. And we'll start with a couple of basic ones. I to the power 0 is defined to be 1, just like with any other number with the real numbers. I to the power of 1, we just write that as I. That's the simplest form. And again, from the definition, we know that I squared equals negative 1. So in order to work out I cubed, we're going to write I cubed as I squared times I, and we can replace I squared with negative 1, so the final answer here is negative I. Now let's take a look at I to the fourth. We can write I to the fourth as I squared squared, and we get negative 1 for I squared squared, so we're replacing I squared in here with negative 1, and so the answer is 1. I to the fifth, we can write it as I to the fourth times I. We know that I to the fourth is 1, so this is just 1 times I, which is I. I to the sixth is I cubed, or I'm sorry, better to write I squared cubed. And we know that we can replace the I squared with negative 1, so this is negative 1 cubed, which is of course negative 1. I to the seventh is I to the sixth times I. I to the sixth we just found out was negative 1, so this is negative 1 times I, which is negative I. Okay, now let's investigate the pattern as we go down the list. What is happening? As we go down the list, there are 4 quantities that are repeating. 1, I, negative 1, and negative I. So these 4 answers are exactly the same. 1, I, negative 1, and negative I. So the answer for I to any integer exponent, I to the n, is going to be either 1 or I or negative 1 or negative I. These are the only possible answers you could get for a power of I. So there are 2 ways I'm going to tell you how to do this. One, the answer is going to be I if the exponent n is divisible by 4. And the answer is going to be negative 1 if n is even but not divisible by 4. Okay? Next, let's take a look at I and negative I. The answer is going to be I if the remainder of n divided by 4 is 1. And the answer is going to be negative I if the remainder of n divided by 4 is 3. Now that's a lot to remember. So, for example, let's take I to the power of 13. If I take 13 divided by 4, then I get 3 remainder 1. So the answer is going to be I, based on what we just said. If the remainder after dividing by 4 is 1, then the answer is I. I to the power of 21, let's see, 21 divided by 4 is 5 remainder 1. Again, the answer is going to be I. Let's take I to the power of 82. Now 82 is even, but not divisible by 4. So according to the rule, the answer is going to be negative 1. Let's take I to the power of 76, or better example, I to the power of 67. So if it's odd, we divide 76 or 67 divided by 4. We get let's see, 16 with a remainder of 3. So when the remainder is 3, the answer is negative I. I admit, this is not the best way to think about it, but it's interesting because it repeats every 4, and so division by 4 makes sense, and what's left over. A good model to think about this is to consider the circle, where you start with 1, and then I, and then negative 1, and then negative I. So this is when the exponent is 0, 1, 2, 3. Let's do it with a different color here. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So these are exponents. You see, when the exponent is 0, 4, 8, or 12, the answer is going to be 1. When the exponent is 1, 5, or 9, the answer is going to be I. When the exponent is 2, 6, and 10, the answer is going to be negative 1. 3, 7, and 11, the answer is going to be negative I. Okay, so you have this kind of nice clock model to evaluate exponents. But when the exponent gets really, really large, like 237, you don't want to maybe use this type of thing. So let me give you an algebraic technique of how to figure out powers of I. So first we'll do some examples where the exponent is even. So whenever the exponent is even, like 346, you can always write this as I squared to half that. Okay, so half of 346 is, what is it, 150 plus 23, 173. Okay, so the reason this is nice is because you can always replace the I squared. You can remember that I squared is negative 1, and negative to an odd exponent is going to be negative. So here the answer is negative 1. Let's do another one. I to the power of 224. Again, this is even, so you can write this as I squared, and then half of that, 112. Again, replace I squared with negative 1 as before, to the 112. This time, negative to an even exponent, that's going to be positive 1. So the idea is if you have an even exponent, write it as I squared to half of that exponent, and then replace the I squared with negative 1. Now, if we have odd exponents, like I squared, or I'm sorry, I to the power of 19, then you can write it as I to the power of 18, 1 less, times I. And then the portion that's even, this portion over here, we can write it using the technique we just learned, which is I squared to half of that exponent, to 9 times I. And then that part we can work out, just like we're doing before. So that's negative 1 to the 9 times I. And negative 1 to an odd exponent is negative. So this is negative I is your answer. So here's another one. I to the power of 225. So write it as I to the 224, 1 less, times I. So here you would get I squared to the half of that. Half of 224 is 112 times I. Replacing I squared with negative 1. Okay, now, negative 1 to the even exponent is positive, so that's just I. There you go. So with even exponents, you know what to do. You write it as I squared to some other exponent. With odd exponents, you want to break it up into two pieces, one of those pieces being I. And there you have it. This is how you compute powers of I.